Alright, welcome back. In the previous video, we created a linked list. We created the node, and then we created the linked list with all the various methods: insert, delete, find, show all, and all of that. Now we're going to go back to the main and actually play with it. So, I'm just going to click on this linked list, and I've already got some stuff already here ready and kind of situated so we can actually play with this. Now, our first step is to create the actual linked list. Now, my linked list is capital L here, and that's why it is capital L here and capital L here. Now, you can call it whatever you want. This is L1. I know it looks like it's a 1-1, but it's actually L1. If you want it to be a little easier to read, you could call it capital L1. It doesn't really matter, but I just call it L1 for list 1. But you can name it whatever you want. The name doesn't really matter. Now, equals new linked list. This is that constructor that I have here. And basically, it's just going to create a head and nothing else. So at this point, we have an empty list. Now, if I try to find something, you'll see at the bottom it says the list is empty. So find in my linked list, if I go down, well, my list count is going to be 0 because there's nothing in here. And that's what I just said. You know, when I created this list, it's 0. I haven't added anything to it. It says the list count 0. The list is empty. So let's add a few more things to it then. If I try to show all, well, what do I see? List is empty because, again, my list is empty. So even show all, I have a little if statement here that checks. Otherwise, you're going to get null pointer exceptions if you try to print something that doesn't exist. That's why you get those null pointer exceptions. Now, if I try to insert, say, 1, well, we'll just go with 1. Well, let's hit it and run. Oh dear. Let's see. Oh, I guess I have to actually do this. Doot. Oh, it still says my list is empty. Let's see why that is. If I insert a 2. Oh, well, obviously. Why does it say my list is empty? Because I'm not printing it after I've done the inserts. So I'll print it after the inserts, and we'll see what happens. Well, there's 1 and 2 in the list, just like I inserted. Now if I reverse these, it's not going to be 2, 1, it's still going to be 1, 2, because of how we built the list. 1, 2. It doesn't matter. It's going to insert them in order. Now if I want to find 1, it should tell me that it's there now, because there is a 1 in the list. So that works. I want to insert a 5. Well, then 5 is going to get inserted at the end of my list, and I'll just show all 1, 2, 5. Now, what if I inserted 2 at the end, after I did that 5? What would that end up doing? Well, it should put 2 at the end of the list, if that's the case, right? Which technically means this linked list is no longer working like it should, putting it in numerical order. Of course, I can insert another 2. I didn't say anything about duplicates, so I can insert as many duplicates as I want. And then, of course, I have to show them. 0, 1, 2, 2, 3, 5. Now, here's a quick question. What if I delete 2? Will it delete all the 2's or just one of them? Well, let's take a look. I go to my delete. All right. If I couldn't find the number, well, 2 is obviously going to be there, so it'll go to the next statement. It'll do my pointer, and it's going to go through the list until it finds 2. Now, what this temp does is it's going to go through the list until the next number is 2, which is what we want. So we go back to my little diagram here. I want to delete 3. I go through my list until the next number is 3. Even if this was, if this was 3 as well. What does it say do? It says, once I find the number, temp equals temp.next. And then I say I deleted that number. So we go back. Temp equals temp.next. Well, this is temp. That's temp.next. I'm basically going to point this pointer past that to the next one, even if it's a 3 as well. So I'm just going to remove the first 3, or first 2 in this case. So you'll see my 2's. Once I do that delete, one of those 2's is going to disappear, but the other one's still there. 0, 1, 2, 3, 5, like that. Now, what if I were to come in here and just say node in? So I'm just making another pointer point to the head, basically. So what this does is I have this head, and I make another variable that just points to that, basically. Now, what if I say in equals in dot next, and I want to show all? Does that change anything? Nope, because it's another pointer. It's another pointer that points to the next item. I can move this all I want, and it's not going to change. Now, if I said head equals head dot next, though, because head is actually where I find the beginning of my linked list here. If I make that go to the next, then I actually remove the item that I'm looking at, the first item in that list. Now, of course, you can play with this all you want. You can try to find some stuff, insert last, insert firsts. If I insert 4 at the beginning, for example, you'll see, there we go, insert 4 first. Let's see. Oh, wait. 1, 2, 4. Oh, that's because it's already at the beginning, right? But I inserted 2 and 1 since there was nothing else in the list at this point. 2 goes in front, 1 goes in front. So it was at the front, but then everything else kind of inserted after it. But play around with it. You can learn a lot. Follow, each little item. You can go back and see how it's inserting that into the list. It also helps if you have a little piece of paper in front of you and draw it out. In fact, that's one of the little exercises you're going to have to do. You should be able to follow this code and basically write out what this list is going to look like when it's actually said and done. If you can do that, then I know you understand how the code works, how a linked list works. Now, what if I were to say print out in.next.next.getNumber? Let's just go with in.getNumber. I'm going to print that real quick. 1. What if I say in.next.getNumber? Well, what's the next item in my list? 2, right? in.next.next.getNumber? 3. So I can actually go down .next as many as I want ahead until I get to the end. Now, if I were to do this, a couple of times, I was at 3, 4, 5. Now I'll be here off into the nether. Watch what happens. Null pointer exception. I went outside the bounds of my list. This is why you want to be very careful with this and make sure that, if you remember in the previous project, I had actual code that said if the next one's null, stop. You're at the end of the list. But go ahead, play with this a bit, and you'll kind of get a feel for it. And of course, as usual, if you have any questions, just feel free to let me know.